Hello and welcome to another episode of CPP Under the Microscope. My name is Sam and today we're going to talk about one of the most common misconceptions in modern C++. The idea that stdmove actually moves things. It doesn't. In fact, if we look at the generated assembly, stdmove doesn't even exist at runtime. If you've been writing modern C++ and using stdmove hoping to squeeze out every drop of performance, today we're going to demystify this crucial utility. By the end of this video, you understand that stdmove is less of a moving truck and more of a very specific type of signpost. We're going to discover that stdmove is purely a compile time transformation with zero runtime cost. It doesn't generate a single byte of machine code. Instead, it works by changing something called a value category, which then persuades the compiler to pick a different function, specifically the move constructor or move assignment operator. We will prove this by diving into Compiler Explorer, also known as Godbolt, and looking directly at the assembly code. So let's start with a quick refresher on the language of values in C++. To understand stdmove, we need to talk about value categories. You've probably heard of terms lvalue and rvalue. An lvalue is something that has an identity and a location in memory. Think of a variable you can take the address of. Here x is an lvalue. An rvalue, in simple terms, is everything else. It's a temporary value that you can't assign to. 10 itself is an rvalue. So is the result of x plus 5. This is an rvalue as well. Now, in C++11, introduced a special category called xvalue, or expiring value. An xvalue is like an lvalue that's about to expire. It's going to be destroyed. This is the key. stdmove takes an lvalue, like our x variable, and casts it into a xvalue, an rvalue reference. By doing this, it's telling the compiler, hey, you can treat this object as if it were temporary. Feel free to cannibalize its resources. I promise I won't need them in this state much longer. So let's look at how it actually does that. So let's open CPP reference and look up the stdmove. It's under general purpose utilities. And here it is. Here is the description. Produces an xvalue expression. It looks something like this. All it does is take the argument, strips off any reference qualifiers to get to the underlying type, and then casts it to an rvalue reference of that type. That's it. It's a cast. It's a static cast with a fancy name. The important takeaway here is that stdmove is a compile time transformation. When your code is compiled, that call to stdmove disappears. It's syntactic sugar. It generates zero instructions in the final executable. If it doesn't generate any code, how does it affect performance? It's all about which function gets called. Let's prove this with some live examples in Code Explorer. This is the perfect tool to see what the compiler is actually doing. Let's write a simple example with an int. Let's add the header first. This is a copy. And this is a move. We have an integer a, we copy it into b, and we move it into c. Now let's look at the assembly output on the right. I'm going to point out the lines that correspond to our operations. We see a move instruction, moving the value from one memory location to another. For int c equals stdmove a. Look at that. It's exactly the same move instruction. There is zero difference. The compiler doesn't care that we used stdmove. For trivial type like int, copying and moving are conceptually the same thing. We have to copy the bits. stdmove is a complete no-op. To see where the move actually happens, we need a type that cares about value categories. Let's create a simple wrapper that prints when it's constructed, copied, or moved. For R2, we get copied. For R3, we get moved. As the move didn't perform the move, it just changed the value of R1 from an lvalue to an xvalue. Because R3's constructor saw an rvalue, the compiler performed overload resolution and chose the move constructor instead of the copy constructor. The move itself, it's performed by the move constructor, not by the std move. Now let's try with a type that actually manages the resource, like std vector. It's a vector with 1000 elements. V1 is a big vector with 1000 of integers. First we copy V1 into V2, then we move V1 into V3. First we see the function call for the constructor itself. This one here. Look at the assembly for the copy. We have V2 equals V1. The compiler generates a call to the vector's copy constructor. We see that it does a deep copy of all the 1000 integers, and that's expensive. Now look at the assembly for V3 equals std move V1. That's this line here, as you can see. This is for the copy. This is where the performance gain comes from. And what happened to V1? Its pointers were swapped with an empty newly constructed V3. So V1 is now in a valid but unspecified state. It's like empty. You shouldn't use it until you assign it a new value, but it's safe to destroy. So to bring it all together, look at the big picture here. The call to std move itself, it's not there in the assembly. The std move you wrote in your CPP code has completely vanished. What remains is just a choice to call to std vector copy constructor versus to std vector move constructor. std move is the key that unlocks the door to the move constructor, but it doesn't walk through it. The move itself is performed by the move constructor, which is just a regular function that happens to take an rvalue reference. Let's see one more example. I'll create two functions, one that uses a manual static cast and one that uses std move. Now, compare the assembly with cast and with move. This is with cast. This is the call to use function. And this is the with move function. They're byte for byte identical, as the move is just more readable way of writing that static cast. It's an instruction to the compiler, not the CPU. So let's recap. std move doesn't move anything. It's just a cast to an rvalue reference. It has zero runtime cost. It's a compiler time transformation. It works by changing an lvalue to xvalue, which allows the compiler to select a move constructor or move assignment operator over a copy one. The real work is done by the move constructor of the type you're using. I highly encourage you to go to Compiler Explorer yourself and play around with this. Try it with your own classes and with and without optimizations. Seeing the assembly for yourself is the best way to truly understand what's going under the hood. This video helped demystify std move for you. Please hit that like button, subscribe for more CPP deep dives, And let me know in the comments what other seemingly magical parts of the language you'd like to demystify next. Thanks for watching and happy coding.